Hello, yes. Thank you very much. At least I can record myself now and then for some few minutes, then I can share. So that is the task that we are going to do. We are using Google Earth, and then we can develop an app that can monitor. Tools that we are going to use are Google Earth Engine, API, then for visualization and layout, as I will show you in a few, using QGIS or GIS Bro. We are going to fill the image, and then I will show you also in the code that we filled up by spatial, temporal, and then spectral. We also have to calculate NDVI, where band 5 is an NIR and band 4 is the red, and then we normalize the difference, and then I will also show you in the code. Pixel-based supervised image classification is what we are going to do. And general workflow for that classification is we collect the training data where we assemble features which have property that stores the known class labels like water, build-up area, and then their properties, like if it is 1, if it is 0, if it is 2, so that we can use those properties for prediction. Then we will instantiate a classifier, and we will set its parameters where necessary. Then we train using our training data. Then finally, we classify an image or a feature collection. That is it for now. And then I will exit that area and then go back to the code. So here in the code, these are samples where I collected all these. These are 52 polygons. This is 51. This is 41. This is 48. And this is just a few. You can add as many as you want, depending on the time that you have. Resources also, and even resources that you have. It's almost raining here. I hope it will not make noise. Just but that is it. So the code will go through. I showed you what I'm filtering. What I was doing about here is getting training points and DVI calculation. This is where I'm selecting band 5, selecting and then calculating. All these other things I'm displaying is here. But this one, the one that I'm displaying, there is a. This one is the maximum, and DVI is where now you can see with 1. So we also have an inspector tool here where I can come and inspect and see, you see. So the green, out of the layers that I have here, there are 3 layers. The NDVI one is also there, and it has got an NDVI of 0.6 there. But at the middle here, I'm not sure if it's going to be 0.6. Yeah, this is very, very, very low. You can see it's very, very, very low, 0.08. So meaning it's really there's kind of no or dead vegetation here. But at this point where you can see there is growing, if I click there and we check the value of NDVI is 0.7. 0.7 is a very good value. It shows that the vegetation here are very, very, very healthy. We can now quantify this thing. Once we know all these other things, we can be able to calculate. You see, we have been able to calculate a lot of statistics here. The top here, you can see I'm able to calculate some statistics. Immediately after classification, you can see I calculated the area of the Nairobi, which is this one. Even you can Google area of Nairobi County is roughly that one. And then I calculate the vegetation. I want to get the vegetation and then calculate the area. So I get the vegetation from the classified image, the one that is equal to 1, because here I called vegetation 1. Okay. Finally, we add that to the map. We also have a vegetation layer here. I can add it there. It will show. So you can see there is a vegetation layer on top, which has got 0 and 1. 0 and 1 means 0 means there's no vegetation, 1 means vegetation. Then you can now calculate the area of the image. You can bring that area in square kilometers, which is 179. We can continue further and do general by every class. For all the 4 classes, we can calculate. So this is where we can be able to get. So you can see we have an object. Then I want to see on a chart these classes, the one that I have calculated, these areas, this 1 or 2, this other one, I want to see. And remember, this is for 2018. So we have also skipped for 2020 because we wanted to get to 2018 one. So you see, it's kind of different from another one. We run that, we print the chart. This is what we get. You can see. Finally, we can export our data. So we need this projection so that we will also use it here. So it is going to be projected or georeferenced. Then geometry is our Nairobi shapefile. And when we export, you can see it go to the scan task and they are all exported. This is the only one that is missing. It does have some errors and I'll export. I think up to there are no much things I can do. I can just go to here and show you what I've done with QGIS. With QGIS, I've downloaded the images, and you can see this the answer here, 2022. And you can see some sections are not predicted well, you see? Some are predicted well. If I remove this vegetation, you can see it is even predicting section where there is water as vegetation. I can still add several images. These are classified image from the Google Earth. You see it has got some background. That's a background color, which we need to do. So we will first of all need to use maybe a better color. I don't know. So we can change into, let me say, we can even use that one, a pelleted one. Then we have 4 classes and we can play so that we can see. So you see, this one is misclassifying some cells. I'm not sure if it is misclassifying. The section that is water, everywhere is being taken as water. You see, and when you are exporting these images, you need to check. There's a section where it asks you about the no color value and the rest. Like here, it will ask me of not, and then I'll apply. Say okay. So you see now I already have, but you see it will miss classes. It's already missing some other classes. It is showing me some other funny things. So because it is 0, I'll still call it 0. See? Now we will just work with that first. We will want to, so we don't have to put anything there. So if we will want to get everything, we will clip. I hope I'm not taking your time and the noise with my party. Local one, here is local. And the noise with my party will not disturb. So I can clip this raster using the Nairobi shapefile. I think I have the Nairobi shapefile here. Yes, this one. On top of this one. So it is going wrong. So I can go to raster and then extract, and then we will extract by the extent where I can make that one. Then I'm using the Nairobi shapefile. Then just run. You don't have to do other things. Then we close and we see. You want to see how it look like. So it might not change so much. You see, it's still remaining. This is a problem because of exporting. How I exported data here. When I was exporting data here. So you see, I did not specify very nicely here on no data. So you need to specify. That is just a that is for classified image. There's another image here. Where was it? NDVI. So we cannot the NDVI. Now you see the NDVI is perfectly fixing. So you can just change so that we understand. We change the color, symbology sorry, and then we go to single layers, or rather, you can even go to the layer, not rather, sorry. I'm in a hurry because of the day. Now you can use discrete, or you can reclassify these colors based on whatever you want. But I want to use this already there, or I can use equal intervals with the 5 classes, and then I classify. That could be okay. And then when I apply this way, you see it is giving me something. So you can see that's got 5 classes, but you're able to identify vegetation. We can use this NDVI to get vegetation by rationalizing, going to raster tools. Raster tools, we use a raster calculator so that we get maybe the maximum NDVI, like the one that we would have included here. So up to there, I think that is the rough draft of what I have done. There is also a section on Python. I will record and share. Now you can still work with this by adding a layout. You can open a new layout or add a new layout print. So if I had a new one, it will tell me the title, and I can say NDVI. Then we have an NDVI, then I can now add a new my map. Say I want to add a new map here. That shows my the map. See? So you can play around with this map because it is connected. You can come here and play with this one. Like just zooming down here, and this one also will go. because it's placed. And if you refresh here by refreshing this other side, and you give it time, it goes a bit of move down. See? So that is, then you can now add other things. You see, there is, you add the text label, the legend, the scale bar, the title, and any other. Otherwise, I will share other things into the GitHub repo, especially this code in JavaScript and also in Python. Thank you.